Hello, everyone, and welcome back to another video. This one, we're going to deep dive into the security pillar of the AWS well-architected framework. And I've gone over the initial setup and everything in a previous video, which I'll link to in the description below. So you can go back and see the operations pillar, which had the initial setup for what we're going to go through and how we get to the well-architected tool in the AWS console and what we do in that. So without much further ado, let's get straight into the security pillar. So like what we did in the operations pillar, I'm going to start off with going over the design principles for this pillar, and it's actually quite similar to what we saw in operations. When we talk about security design principles, we definitely want to start with a strong identity foundation, knowing who's coming in and what sort of permissions they have, and being able to manage that centrally from one place is going to be a very important factor in how you secure your entire environment and the resources that you're responsible for. Enabling traceability is another design principle. So this speaks more towards being able to know exactly what's happening across your entire landscape. So monitoring what's inside the systems, what kind of activity is happening within your applications and your systems, and then defining the conditions on which you want to be alerted so that you know that something unexpected is going on, and making sure that you've got all of these key changes and modifications that happen in the system are being captured as audit actions, so that when something does go wrong, you have a clear path to recreate through those logs and through those audit actions what was going on and what specific change happened and by whom. So that level of traceability is an important aspect of making sure that you've got all the right pieces in place to have your environment secured. Applying security at all levels. This is a design principle where we talk about defense in depth, making sure that you're not just keeping security as as a layer around your environment, but rather each portion of your environment should have its own security baked into how that specific layer is accessed. So starting all the way from your network to your computer environment, looking at how you're storing information and storing your data, how these systems talk to each other. Each of those layers should have their own security checks and balances added into them, so that you have to pass through each gate in the right way in order to get to the next piece. And when you do that, it just makes it that much harder for somebody, a malicious actor, to come in and take any kind of bad action within your environment, because now they have to break through every layer in order to get to that next stage. The next piece around automating these security best practices, obviously, you don't want all of these, these controls that you're creating to be done manually. That way, when something changes in the environment, somebody will have to go through and make sure that all those controls are reestablished. But rather use code as a way to, enforce that security best practice within your environment. Policy as code is another sort of paradigm that's getting very popular nowadays, and especially with in the cloud, everything is defined as a policy, and it's something that you have to define in some kind of a code language, whether it's JSON or YAML or something else, where it's more specific to that system. But that allows the team to make sure that they've got all of the things that they want enforced. They have been documented and captured as part of the code. So that way, for sure what is being enforced, and if something is missing in that, the team can, as part of their reviews, they can go back and look at what the gaps might be, and they can add on those things directly in the code. Having your data protected in transit and at rest. So not just getting your data protected in transit, which is using secure socket layer or TLS, having end-to-end VPN So you've got a secure channel in place. That's one aspect of it. But also when it's being stored in those, whether it's in EBS volumes or in S3 buckets, when your data is being stored, you want to make sure that it's being encrypted even when it's kept at rest. That way, if somebody does get inappropriate access into that environment, they cannot just read the data. They still need more access in order to decrypt that information and actually get access to it. So that is part of the security at all layers paradigm also. Keeping people away from data is another thought process where making sure that you don't have humans logging in and directly accessing and processing information, but rather using applications and code in order to perform those actions. That helps you with one, not having unnecessary transactions or actions being taken when somebody did not have to go in and perform that work. Second, you've got your code, which for sure is going to operate in a consistent manner. And so you have that code to audit and say, here are all the steps that can and should be taken when this particular work item has to be completed. And then you can also use that same code to inject all your audit logs and other monitoring information that is required for any kind of analysis to be done after the fact. That way, it happens in a consistent fashion. You can use other tools to know and be alerted on when something unexpected is going on within your environment. And then, despite all of these things, there may be a time, that an incident actually happens within your environment. So being prepared for those security incidents to happen, having a process in place, having the right tools in place, having the team trained to know how do you actually detect when something is going wrong, how do you get all the information that you need to make your decisions whether or not this needs any additional actions, being able to take those actions and then repairing and coming back into a regular normal working state. All of these things should be thought through, tried out, do response simulations, do your fire drills basically, so you know exactly what steps to follow when there is a real problem that happens. And these are, these are overall, they're pretty much common sense things, but it's good to have them identified and listed out so that the whole team is on the same page around what we should be focusing on and why we're doing things in this manner when we're operating in AWS. Now, when we talk about security within AWS and the security pillar, it is going to focus primarily on 6 areas. And the questions would be more or less just within 5 areas, which are part of the security white paper. And I would recommend reading that white paper. That really gives the foundation and the background on how AWS thinks about security, how it thinks about the foundational shared responsibility model, and how each of these different areas across identity and access management, incident or problem detection, security event detection, uh, protecting our infrastructure, which includes network and compute, and then looking at storage, not just in transit, but also at rest, and then being prepared for those incident response areas. That's how the security pillar is organized. And so when we switch over to the tool, we're going to go through all the questions that formulate these 5 areas and evaluate the security pillar as per the AWS well-architected framework. So let's switch over to the tool. And here's our first question on the security pillar: securely operating the workload. This includes, a lot of things that are around the workload. So making sure that your applications are being separated out into different accounts, and think of an account as a blast radius. So if something goes wrong and you've got a security incident, somebody's just, taken access into that account, that account boundary is the maximum extent of damage that can be done, by that malicious actor. And that's just by design. AWS does not allow anything beyond those accounts unless you've got, cross account permissions granted, and that also requires specific actions. And so it won't be automatically made available to somebody else. So by separating workloads into different accounts, you're actually limiting the damage that can happen if there is a breach. And then, the next piece is once you have separated them into different accounts, you secure it. You make sure that you've got the right, controls in place, and that's part of our, evaluation here, identifying which controls we want to have in place so that the AWS account is secured, getting root permissions locked down. All of those things are going to be talked about when we go into the next question. But basically, going through the steps of making sure that your AWS account itself is being secured. Identifying and validating the control objectives. This also ties back to your compliance requirements. So whether you have HIPAA or high trust and PCI compliance or FedRAMP compliance or in NIST 800, 53 or 171 compliance models that you're using, those will drive the kind of control objectives that you would need to have in place. So identifying which ones are relevant to your environment will help you make sure that you've got the right pieces configured within AWS to meet those objectives. Keeping up to date with security threats, having a team on those mailing lists where the information comes out about when something is going wrong, and also using tools that are available from within AWS, which will inform you when there is a security threat out there that requires you to take action and lock down things to prevent any breaches. And then the next piece is keeping up to date with security recommendations. So it goes hand in hand with knowing about the threats, but also what you can and should do in order to prevent those threats from affecting you and your environment. Then automating testing and validation of security controls and pipelines it's part of the maturity model where more and more applications that are using DevOps as part of the pipeline for deploying your code into the next environment, having your security objectives being tested within that pipeline. So one of the steps as part of your testing should be security testing. So you've got your functional testing, you've got your load testing, and you should also have security testing as part of the pipeline so that if any of those pieces fail, you don't promote that code over into the next environment. Rather, you pause and you send it back to the team to say, go fix these issues before this code can go over into the next environment. And that helps to make sure that your production environment stays safe and it does not get any of those vulnerabilities feeding over into that environment. Using a threat model is another way to identify and prioritize the potential risks. Threat models are potential areas where ways in which somebody could get access into your environment and then do damage. So what are the different ways in which you could get that damage happening in your environment? Defining that into a threat model and then looking at those risks to say which of these risks are going to cause us operational and revenue kind of or like an impact that is more than what we will be able to digest or take on, and then using that threat model to upgrade your security or make sure that you've got the right tools in place so that you can detect those issues and you can take action when something does happen in any of those areas. So things like somebody can get elevated access. That's one of the threat model pieces that you could have. And so how would you prevent somebody from getting elevated access without having proper privileged access management in place? That's what will drive having a good PAM system, like a privileged access management system in place, so that you can prevent that particular threat that will exist in your environment. Then just taking a step back and looking at what are the new security services and features that are coming out, whether it's from AWS or from third parties and partners, and how you can incorporate those pieces into your environment, the ones that make sense and that will actually make things simpler and more streamlined for your team. That's the stuff that you would want to prioritize and get implemented into your environment. That way, the when you reduce the burden on the team to go out and check different things or have different integrations in place, you're actually making it easier to identify and respond to any particular security threats that you might have. All right, so moving on to the next question. The next question is managing identities for people and machines. And this is more around getting your whether it's a username, but if you're defining identities through uh, IAM or through a federated system, this is what the, the the pillar question focuses on. So first of all is making sure that you've got strong sign-in mechanisms. So it's not just having a strong password policy in place, but also making sure that you've got a second factor authentication, whether it's through a software token like the authenticated app or something else that you use. Uh, there are all these third-party tools that actually come with a token that changes every few seconds. So you use that as a way to confirm that you've got something else in your possession that you're using to sign in addition to something that which is your password. So that's on the first one. Having those helps reduce the risk that you have from a security perspective. Using temporary credentials. So if you don't need to have access into your environment that you that needs to stay on, and try and get to a functioning architecture where you can operate with temporary credentials, and a lot, a primary way of doing that would be through single sign-on tokens. So when you log on with your single sign-on, you get a token, and that token is valid only for, say, 4 hours or 6 hours or 8 hours. Like you can choose how long it's going to be valid, and after that time period expires, that token is expired. Then you have to re-log in. You have to re-sign in. So what that does is, even if that credential is exposed in any way, it reduces the amount of the duration of the time that it can be abused, and beyond that time, that credential will stop working. So even if it was exposed, it's just not valid anymore, and nobody can use it beyond that time period. So that helps with, again, limiting the damage that can be done with a breach that comes in. Storing and using your secrets securely. Obviously, you want to make sure that anything that you've generated as a secret, it gets stored in an encrypted fashion. You're not just writing it up on a piece of paper and sticking it on your laptop. Those kind of things should not be happening. Relying on a centralized identity provider is another way to minimize the number of areas where you have to make changes and updates when somebody's, say, password has to be updated or an identity has to be changed. If it's all centralized through one identity provider, then all the other systems reference that one identity provider in order to get their authentication completed. And that helps with updating things in only one place, and everybody else, all of the systems, because they're just passing through authentication over to the centralized identity provider, they don't have to maintain their own secure areas for maintaining identities and passwords. And so you're reducing the attack surfaces and potential areas where something can go wrong. Auditing and rotating credentials periodically is a very important part. Many times it happens that developers they'll create these keys for use with their API, but then they forget to rotate them, and so it's a year goes by and it's still using the same old key, and nobody's actually checking whether or not that key is being used appropriately. What if that key got exposed to somebody else, and now they're just coming in and using your services as they see fit, and nobody knows about it? So this is an important aspect that has to be a part in the process, where regularly you're able to go in and look at what each of these credentials are doing. Are they being rotated on a regular basis? At most 90 days, for those kind of keys, and also look at the audit trail to say what are these keys actually performing, and are those authorized actions, and should they still be doing those actions, right? So that's part of the check-in that you would periodically do to confirm that you're not unnecessarily giving somebody permission to take actions that they should not be doing at that point of time. And leveraging user groups and attributes, that's part of it's been part of the secure systems for a long time. Don't assign permissions to a user, assign permissions to a group, and then make a user a part of that group so that they get that permission. That makes it easier for change of, when staff changes happen, or if somebody else needs to be added to the team, you're not going through and creating extra permissions for the next person. You're just adding them to the right groups, and that allows them to get the permissions that they need. So these are the kind of things that make it easier for the security team to make sure that identity for people is being maintained in an appropriate fashion. The next one focuses on maintaining permissions for those people and machines. So the first part was making sure that you're talking to the right person, when an interaction is happening. So you've maintained the identity. And the next piece is the authorization. Like, what can this person or this machine do when they have been authenticated and they are who they say they are? So from that perspective, having a clear definition of what your access requirements are, making sure that you've got the least privilege only, give them just enough rights to perform the exact work that they need to get done. Just because it's easier to give somebody admin access and say, okay, now go figure it out. Don't bother me. Like that should not happen. If a person comes in and says, hey, I need access to this service, the next question should be, to do what? And what exactly do you want to get done in that service? And they should be able to define that as part of the as in a way that defines the specific API calls that they would want to make in those within that service, whether it's reading information, writing information, or performing specific actions. Take those API call actions and give them only access to the specific API calls that they are being authorized to use. Don't give them more permissions that they need to have, because that has the potential of being abused. Establishing emergency access process. This is something that should be in place where so that if there is a problem and your IAM permissions are locked down because somebody came in and took away your IAM access, have an alternative emergency access approach in place, where it could be some kind of a break glass account that is established and nobody has access to modify that. And so that way you're ensured that at least you would be able to go in using that process. Or if you're using, say, single sign-on, then having a separate IAM user that would not get impacted with single sign-on being down or not available. Um, the next piece around reducing permissions continuously, that goes back to the least privilege access model, where if you do regular audits of what each of these different users are doing, and if they have been granted access to a specific permission set and they're not actually making those API calls and they don't need that access, then it should be removed. So reduce those permissions on a regular basis. Defining permission guardrails for your organization also allows you to reduce, the scope of what those permissions will allow a user to do. So you can limit that to only a few specific resources, or you can limit that to some accounts only. That way, it's not like you're giving somebody access to go out and do this for every S3 bucket that you have, but you can specify only these kind of S3 buckets are what you would be able to work on, or the kind of resources that you'll be able to work on. So those permission guardrails will help keep limiting the damage that can be done with any kind of a breach that might happen. Manage access based on lifecycle. So this is another aspect that normally gets overlooked. A developer would be working within the dev environment and making code pushes, or those kind of things, right? So define the access model that's required for a developer to perform their work at that stage of the life cycle. When they are pushing information, or they're pushing their code or the application over to, say, the test environment, then the kind of permissions that they need in a test environment would be very different. They don't need code deployment permissions, but rather they need probably permissions to go and read the logs of what's happening in the test environment, so that if there is a problem and there is a bug that's reported by the testing team, they are now able to go into the test environment, look at the logs, what happened, and then go back and make changes on the, in the dev environment within their code. So managing that access based on the specific life cycle of which environment are you in, or which stage of development you're in, and that changes the kind of permissions that you get. So that would be another way of limiting the kind of damage that can be done. And then analyzing your public and cross-account access. This is just very similar to the least privilege access model and the kind of analysis that you're doing. It just comes down to repetition of not don't just set things up and let them run, but keep looking at what you've set up and make sure that you're questioning every piece that's been authorized or allowed to say, do you still need it? And if you still need it, have a justification in place. And if you don't need it, then just remove it, reduce it, get rid of it. That way, you're not keeping that open for somebody to leverage and misuse. And sharing resources securely. This is another piece that uh, you know that a lot of people don't pay too much attention to. So even when you're sending out those those tokens or AWS keys to your team members, don't just put that in a Teams chat or a Slack channel. Make sure that you're sending it to them in a secure fashion. Uh, Use it with an encrypted file, send it to them with encryption in place, or use some kind of third-party service where, something like a one-time secret, where as soon as they look at the contents, that gets destroyed, the message gets destroyed. So that makes sure that nobody else is able to, in transit, get access to that information that you shared with them and then misuse it. All right, so let's move on to the next piece. Um, Detecting and investigating security events. So this is about making sure that you've got the right pieces in place to know when there is a security incident or event happening, and then you can actually investigate what's going on. So having your services and applications logging into a centralized location, and that centralized location where your logs are going should not be modifiable by anybody. That's an important aspect of configuring this properly. That way, uh, you're not allowing somebody that's doing malicious activity in your environment to go in and just scrub out all of their footsteps, or the trail that they're leaving from the logs, and that way you'll never know that they actually came in and did something, right? So having logs going into a separate area which is not modifiable by anybody is part of having that security system in place. And then analyzing those logs and those findings and metrics from a central location. The same thing, the same idea about having all the logs coming into one place, but then using tools to actually sift through what's happening in those logs and then find any anomalies. That's part of tools like CloudWatch and Splunk and Sumo Logic. Like these are all third-party tools along with the AWS tools that can actually that excel in that space, and then we should use them to perform that specific role. And then if there are events happening, automating a response to them. If you do find that, let's say, there is unexpected activity in an account that should not that's not expected to have any activity at any point of time, uh, then lock down that access, take away their permissions, right? Those could be automated responses that happen to such kind of events. And if there is an authorized thing, then maybe you can go back and reverse it, uh, or disable that particular response or that particular action that was taken. But you do want to be more on the proactive side and lock things down first, and then figure out what was going on. And implementing actionable security events, that's similar to what we were talking about in terms of the automating aspect to it. So you want to make sure that those security events that you're detecting, they have some sort of an action that can be taken along with it, and those actions have been implemented so that each security event that's being identified is also being acted upon. It's not just a notification going out to somebody. All right. The next piece around is about protecting your network resources. So for this, especially within AWS, the way AWS's network is set up, what you want to do is you want to have your network as in different layers, and this would be from a classic network design perspective. Think about that as your within your VPC your different subnets. So you've got, a public layer, a public set of subnets. You have your application set of subnets, your database set of subnets, and stuff like that. But what you want to do is even between those subnets, you want to control the traffic and specifically and explicitly allow traffic to not just enter a subnet, but also leave that subnet. And so those use network access control lists, use your subnets and way to protect the traffic that's flowing between these resources. And you automate that with the right tools in place. There are, if you look on this side, on the right hand side, you can see some information around what kind of tools are going to be available for you to perform that work. So things like intrusion detection and prevention tools are going to be useful for automating that network protection. And AWS already allows you to configure your network protection in that fashion. And then implementing those. So making sure that you've got that level of inspection in place, and then you also protection is being built around your application, like a firewall being put around your application layer, so that any unexpected activity that happens, you're able to lock it down within that firewall. Okay. The next one is protecting your compute resources. And for this one, within your specific compute environment, we want to make sure that there's vulnerability management is being implemented, making, for your operating system, making sure that you scan for any vulnerabilities, but you also keep patching on a regular basis so that those vulnerabilities are being fixed and removed. And then continue to reduce your attack surface. The number of, as you increase the number of compute objects that you have out there, it is increasing your attack surface. Any of those can be impacted. So minimize the number of instances that you have to use, but then also within each of those instances, remove anything that's unnecessary. So remove extra code, remove applications that are not being used, disable any inbuilt modules that are not required or that are not expected to be used. That way, even if by accident or if they're just available, then somebody could use that as a way to leverage its vulnerability. But if it's not available at all, then obviously that attack surface has been reduced. And then implementing managed services allows you to not be responsible for the underlying infrastructure layer. So use as much of AWS provided managed services like RDS for database management. So instead of having your database configured on an EC2 instance, where possible, where it's relevant, prefer to use RDS. That way you don't have to worry about securing the underlying infrastructure and the network aspect of it, but rather you can focus on just securing the database itself. Automating compute protection. So if there is a problem that happens within your environment, then being able to lock down that particular compute resource so that it's not being leveraged anymore is something that can be automated. And then also within your OS compute environment, or if it's a virtualized environment, making sure that each of these compute resources, they're just working within their own defined boundary, and they cannot, like from a memory perspective, they're not able to jump over and get access to a memory block that is part of another compute resource. So having that level of compute protection is also, that's an important aspect which is automated by your hypervisor or your virtual machine management system. Enabling people to perform actions at a distance talks about being able to log in and take do remote actions um, instead of doing things like you SSH into a server and then you run a command. So that requires a human to go in, type out the specific commands, and then the output of that command is captured, and then you take action on that. Instead of that, the alternative is that you define specific scripts that that an agent is able to implement on behalf of the user, and that agent is then going into the compute instance or your EC2 instance, for example, running that script and then sending you back the output of that script. So in EC2, we have SSM and run documents as one of the ways that you can do that. So, or you can just issue specific SSM commands without actually having to log in to that system yourself in a step-by-step manner. By enabling your teams to perform work like that, you're actually reducing the number of times that somebody has to manually, provide their password, and reducing the number of ways in which that things can go wrong. Validating software integrity. That's one of the things that I've seen. A lot of teams actually skip over that one part, especially when it comes to using software that has open source components. So a lot of times what happens is, we download and we start using these open source libraries and tools and languages, and we may download that software, but we normally don't do the MD5 hash check and confirm that that software has not actually been modified by somebody else. So you're not getting a malicious version of that software. Um, Having that as part of your pipeline and as part of your best practice is going to help you remove that one extra layer through which vulnerabilities can enter your system. So what you're downloading, you're making sure that it came from an authorized source and it has not been modified from the time that it was packaged is validation that you can have in place then. Now, the next piece, the next couple of questions are going to focus more on the data aspect. So classifying your data helps you know what is the level of confidentiality or sensitivity that your data has, and that will in turn influence the number of controls that you should have in place in order to protect it. So first step is, do you even know what kind of data you have in your workload? You work with the different teams, you see whether or not you have personally identifiable information, and if you do, then you want to protect that data in a way that is stronger than if you have publicly available information. So, a website where you've got files which are being stored and made available to the public, and it's for anybody to see, that will have a different set of controls than an S3 bucket where you've got very sensitive, personally identifiable information or sensitive data that's being stored, and then you want to add extra protection controls within those buckets, make sure that they're encrypted, make sure that only specific people have access to it, and every access is being logged. All of those extra controls will then have to be added on if you know what kind of data you're dealing with. Which we just talked about the defining of those data protection controls that will align with the level of data sensitivity that you have. A lot of organizations define their data as either being publicly available or public access. It could just be internal information, which does not really require additional controls, but you just don't want that to be made public, right? It could be confidential or it could be highly confidential and sensitive, in which case it has a higher level of protection degree around it. Automating that identification and classification is helpful. Um, that is typically managed by different departments or different divisions. But if you know what kind of information you're gathering and collecting, then you should be able to tag your buckets and your data stores in a way that you can identify very easily what kind of data is being stored within those, and then automating that as part of your CloudFormation scripts or as part of the scripts that you're using to deploy your code will be helpful in managing the life cycle of your data, which actually feeds into the next portion where you've got a life cycle defined for your data so that when data is being produced and when it's in usage stage, and at some point it becomes obsolete. And so at that point, you want to archive and retire the data from active use. And so having that life cycle being maintained also aligns with the kind of identification and classification that you would have for that data. All right. The next one talks about protecting your data at rest. So making sure that you've got proper key management in place. So if you're encrypting your data, then it's important that the keys that you use to encrypt that data, they are being maintained in a secure fashion. And then you go on to enforce encryption at rest. That means everything that comes into your storage environment is going to be encrypted. So it's not going to be a hybrid mode. Everything gets encrypted when it's being stored on disk and physically on disk. Automating data at rest protection. So this is not something that should be a manual step. It is something that's as part of the data store process is where you've got a way for it to be encrypted and protected. Enforcing access control talks about making sure that you've got the right people, authorized people only get access to your data, and 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 even the keys that they use in order to access that data are rotated on a regular basis, so that if there is a key breach, then that gets limited in how much time the data is made available to somebody else. It could be restricted because that key gets rotated, and then now you have to re-authenticate in order to get access to the data again. And then using mechanisms to keep people away from data. This is very similar to what we talked about with using mechanisms to keep to perform compute actions from a distance. For data also, you don't want to give people access directly to your SQL server or direct access to the S3 bucket where they can go and make changes, but rather have them use tools to go and access the data or make changes to the data, so that you've got a proper tracking and insight into what's going on and what's changing and how it's changing, so that if something goes wrong, you know exactly what to look for. All right. This one around protecting your data in transit. So when you've got data in transit protection, so you're typically going to use something like secure socket layer or TLS nowadays. So those those security mechanisms, they operate with keys and certificates that are being exchanged. So making sure that you've got your certificate management being performed in a secure manner and your keys being maintained in a secure manner it's an important prerequisite for your encryption to happen in transit. Making sure that every interaction, every time data leaves from its source and going to its destination, its end to end is encrypted. Um, Many times you might find that once data reaches within your network, then from the load balancer to the compute instance or to the storage, it's unencrypted. You want to make sure that each portion of your network hop that you have for your data is is covered under encryption. And then detecting unintended data access should be automated. This is part of identifying when uh, in transit data is being tapped into, or if it's getting rerouted and things like that. Uh, if that is unintended, then there should be a way to detect that. So there are tools that will let you do that, and so having those tools in place will make sure that you've got a way to know if it's not reaching its destination in a direct manner, but rather it's going somewhere else, getting modified, and then coming to its destination. That's that's already detected. And authenticating network communications. So don't just uh, the tools that we have are they're set up in a way that it will you know ask for an authentication key, and then it will validate that this is something that is an authorized or a known key for that particular partner that we have. And so that authentication has to be in place before you actually start performing the network communication. So this is all managed as part of secure setup of the TLS tunnel that we have, but making sure that that's being done and it's configured to operate in that fashion is part of what this particular control talks about. All right, so now moving on to the last question on this pillar. Um, This is around the process for anticipating, responding to, and recovering from incidents. So when there is a problem that actually does happen despite all of the controls that you've got in place, do you know who the right people are and which other external teams you want to bring in when there is a problem? Do you have an incident management plan in place that talks about specific steps that should be taken? What kind of communication has to happen? How do we, bring the whole team together? Are we going to use, a Teams meeting or a Slack channel? All those things should be part of your incident management plan that's predefined so that there are no decisions to be made at that point when there is a problem. You're just literally executing on the plan. Preparing forensic capabilities talks about when there is a problem, or let's say there is a breach and you've now identified the problem and you've got the information that you need. Do you have the tools to actually go through the logs, go through your monitoring system, and identify where the problem actually started and what were the clues that were being dropped along the way that would have helped you detect and prevent that problem from happening, so that you can actually update those procedures going forward so that the same thing does not happen again next time, and you know exactly what allowed somebody else to come in to your environment. Automating that containment capability is something that we did talk about earlier. If something goes wrong, there's a breach, having having tools in place or code in place, or scripts that will cut off your network access, that will we can even do things like as part of your AWS organizations. One of the things that I do recommend as part of the design is having a quarantine organizational unit in place, so that you can take an account that has potentially been breached and you can move that over into the quarantine OU. And what that does is it will remove all kinds of access as part of the OU's policy definition. And you haven't touched your account and you haven't changed anything in there. But while it's in the quarantine OU, you can basically perform some kind of forensics on it, identify where the problem was, and then once you fix the problem, then you can bring it back into its correct, organizational unit, and then that re-enables access into that account and into the application. So this allows you to have this pre-provisioned access and tools that will allow you to handle any kind of a security incident in a way that does not disrupt the rest of the environment, but only that particular uh, account or tool can be used to determine what went wrong, fix it, and bring it back into normal functioning state. And then the last piece around this, around run game days, this is about having tabletop simulation exercises, and sometimes even you can go a step beyond that, and you have a separate environment stood up where you can actually inject faults and security incidents, and then have the team run through them to make sure that they understand the process, they know how to go look at their logs, how to which tools to use across each of those steps as part of your incident management plan, and that this is being done on a regular basis so that the team stays up to date in how to operate when there is a problem. And these are all pieces that work along with all the other controls that you've got in place that will try to prevent an incident from happening. But if it does happen, then you know that your team is going to be prepared if you've been doing all of these pieces. So that takes care of all of the security questions that we have in the security pillar. And I'm going to wrap it up here. And in the next video, we're going to talk about the reliability pillar. So until next time, thank you.